Okay, let's continue talk about acid and the bases. Acids and the bases. Okay, the first one, acids. Acids can be divided into two categories. One is called strong acids. Strong acids are able to be completely ionized. Okay, then this is the reaction uh, like this, and the acid and interact with the water and form a hydronium ion and a negative ion. Okay, it's one direction only, completely ionized. Okay, um, weak acids are partially ionized, and weak acid ionization reactions has two parts. One is a forward reaction, another one is a backward reaction. The forward reaction is the acid and water form hydronium ion and a negative ion, and a backward reaction is the hydronium and the negative ion form acid and water. Okay, those two parts eventually comes to an equilibrium. Okay, since this weak acid ionization reaction can reach equilibrium, so we can calculate equilibrium constant. Okay, that's the equation. Okay, the equilibrium constant is represented by K, capital K here. This equation is K equal to the product of hydronium concentration and negative ion concentration divided by acid concentration and water concentration. All right, that's the equation equation for calculating equilibrium constant. Because water concentration is essentially a constant, especially when the solution is dilute. Okay, the concentration is around 55.6 molar, and because of this, another constant called acid dissociation constant Ka can be calculated. This acid dissociation constant Ka also can be called acid ionization constant. Okay, this is the equation for calculating Ka. Okay, Ka equal the constant product of hydronium ion and a negative ion concentration divided by concentration of acid. All right, from this equation you can see if the Ka is higher and the hydronium ion is higher, so the acid is strong. If the Ka is small, the hydronium ion is small, the acid is weak. So another thing we want to talk about is hydronium ion. Hydronium ion has the Ka value of 1. Okay, so all the strong acids has have Ka larger than 1 if the acid with the Ka larger than 1 is a strong acid, and if the if acid has a Ka smaller than 1, that acid is a weak acid. Okay, that's about the acid. Okay, next let's briefly talk about the bases. Very similarly, bases also can be divided into two categories, and one is the strong bases, another one is the weak bases. Strong bases is the bases that can be completely dissociated, and this dissociation form hydroxide ions. Okay, the hydroxyl ion has a Kb value. Kb value are equivalent to Ka for weak acid. It's a weak basis. Kb value for hydroxyl ion is 1. Okay, actually all the strong bases, because they completely dissociate into hydroxyl ions, so all the strong bases have the same Kb value of 1. Okay, weak bases are partially dissociated, so all the weak bases have a Kb value smaller than 1. Okay, here you can see the reactions formula, and that also has 2 parts. And the first part is forward, the second part is backward, and the base, the B is a base, water here is acid. BH plus is the conjugate acid of B, and this hydroxyl ion is a conjugate base of water. This is how the Kb is calculated. Kb equal product of conjugate acid concentration and hydroxyl ion concentration, and divided by base concentration. All right, this is base.